Welcome back to the Deep Dive, where we tear through the source material so you can walk away feeling immediately informed, strategic, and ready to tackle the product world.
Today we are going into something really at the heart of modern product management.
Absolutely. We're not talking about the mechanics of coding or, the nuances of design today. We are focused on the crucial high-stakes difference between two concepts that might sound similar, but, well, they determine whether your product lives or dies.
And that's building to learn versus building to earn.
Exactly. Building to learn versus building to earn.
That distinction is, it's truly the fundamental philosophical shift of modern product organizations. Historically, companies just built products, and they hoped customers liked them.
Right. A build it and they will come sort of mentality.
Exactly. Now, we acknowledge that committing time, serious engineering resources, and a vast budget before you know if something works is probably the single greatest cause of corporate failure.
So product success today is measured differently.
It's measured by the speed at which you reduce uncertainty.
I love that framing. And the sources we dove into, which are, heavily influenced by the Silicon Valley Product Group framework, are all about minimizing that uncertainty. They lay out this rigorous, almost scientific methodology for using prototypes, but not as, rough drafts of a future product.
No, not at all. They're viewed as disposable scientific instruments.
That's the core shift, isn't it? The modern view is that a prototype is purely a question.
It's just a question. It's an artifact built solely for rapid learning. It exists to be stress tested, to be broken, and then to be thrown away once it has delivered its single purpose.
Which is mitigating risk.
Mitigating risk, that's it.
So our mission today, then, is to arm you with this entire strategy. We're going to unpack prototype fidelity, meaning, how real it looks and how you strategically match that realism to the four great existential risks of product development.
We're calling them the four horsemen of product failure.
I like that. We'll cover the different flavors of prototypes, the decision flow top teams use to choose them, and, critically, how to run internal critique sessions that actually result in clear decisions.
Instead of just devolving into, political debates about who likes the color blue.
Exactly. By the end of this deep dive, you will have a clear, structured view of how top product organizations validate their ideas and minimize their failure rates before they ever write a single line of production code.
And this isn't just about making things look good. This is about making sure your team is learning faster than your competitors and, maybe more importantly, faster than you are spending money.
Okay, so let's unpack this core dichotomy, discovery versus delivery. This is really the fundamental strategic split in the product world, and understanding it dictates everything else we're going to talk about today.
It really does. So product discovery is building to learn.
And product delivery is building to earn.
Precisely. And prototypes belong entirely firmly in the discovery phase. If you are building a prototype, your goal is not to ship it. It is never to ship it.
Your goal is what then?
Your goal is to invalidate a bad idea or validate a good one as quickly and as cheaply as you possibly can. It's the cheapest mechanism a team has for validating those underlying, make or break assumptions.
And those assumptions are perfectly mapped by SVPG's four big risks.
The four horsemen.
The four horsemen. I love this framework because it forces a kind of ruthless clarity. If you're starting a new initiative, you have to ask yourself, which of these horsemen are we confronting right now?
Right. And every single prototype, whether it's a sketch on a napkin or a fully interactive flow, it has to be created explicitly to test and mitigate one or more of these risks.
And if you can't state which risk you're testing?
You shouldn't be building the prototype. You're just playing around.
Okay, let's run through them. Because they are comprehensive, but I think they're often misunderstood, especially in how they interact with each other.
For sure.
First up, the big one. The one that kills most startups, and frankly, most large company initiatives too.
Risk number one, value risk.
The question is so simple, but so hard to answer. Will users or buyers actually care about this solution?
Care enough to adopt it or pay for it or, and this is the key part, change their existing behavior to use it.
Yeah, that's a real hurdle.
It is. Because if you build the most usable, feasible, and legally compliant product in the world, but nobody has an acute need for it, you have failed the value risk test, period.
You're asking, does the pain we are solving justify the cost or the effort or just the cognitive switch the user has to make to use our thing instead of their old thing?
And value failure is so often masked by initial enthusiasm. People will tell you, yes, that sounds like a great idea.
Of course they will. They want to be nice.
But when the time comes to actually open their wallet or change their workflow, the value just isn't strong enough. And we need prototypes to measure that willingness to commit, not just their stated preference.
I think we sometimes forget how high the bar is for value risk. We're not just looking for mild approval. We were looking for a clear, almost desperate need.
If the user can live without your solution, your value risk is still unmitigated. It's that simple.
Okay, so that's value. Moving on, the second risk is usability risk. This one feels simpler, but it can be just as deadly.
Right. A product might solve a massive, painful problem, so high value, but if the learning curve is too steep or if the flow is just confusing, users will abandon it.
And we're not just talking about aesthetics here, are we? It's not about whether it's pretty.
Not at all. It's about cognitive load, navigation, clarity, task flow efficiency. You might have a complex B2B tool that is incredibly valuable, but if the user has to click 6 times to approve a task that took 2 clicks in their old spreadsheet.
You have failed usability, and all that value you built is lost. It's trapped behind a bad interface.
That's a critical point. Usability is the vehicle that delivers the value. You really can't mitigate the value risk unless you mitigate the usability risk first. The two are, for all practical purposes, inseparable.
Then you hit the constraints that live inside your own organization. Which brings us to risk 3, feasibility risk.
Which is, simply, can we actually build it?
And this is where we bring the engineers to the table early during discovery to check these constraints.
Exactly. And feasibility is often mistakenly thought of as purely technical, can the code run? But it's much broader. It involves checking all the internal constraints.
Like what?
Like, do we have the time? Do we have the available talent with the right skills? Can our existing technology stack handle the load or the integrations or the new algorithms this feature requires?
You could have a great idea that users would love, but it's just not feasible for your team right now.
Right. We might want to build a truly instantaneous global payment system, but that is simply not feasible given our time constraints, current regulations, and our, legacy infrastructure. Prototypes in this domain are built by engineers to test technical reality, not user interaction.
Okay, and finally, the overarching strategic check, which I feel often catches teams by surprise. Risk 4, viability risk.
This risk ensures the solution works for the business as a whole. It's looking at the holistic picture beyond just this one feature for this one user.
It's a check against unintended consequences.
It is. It covers legal compliance. Are we allowed to collect this data? Does this comply with regional regulations like GDPR or CCPA? It covers financial models. Will we make money at this price point? What is the actual cost of goods sold, the code GS, to run this feature at scale?
And ethical implications, too.
Huge. Are we creating a dark pattern? Are we optimizing for a behavior that harms the user or the company's reputation in the long run?
Viability is kind of the silent killer because a product team can nail value, usability, and feasibility. But if they fail viability, the whole thing is shut down by the CFO or the legal team, sometimes months into development.
Oh, for sure. A great example from the source material involves data collection. A product might be massively valuable and perfectly usable, but if it requires accessing a highly sensitive user data stream that triggers a massive legal compliance audit or creates an unacceptable brand risk,
Like being seen as overly invasive.
the product is dead. Viability demands that the company can sustainably offer the solution without self-destructing.
So the prototype is basically cheap insurance against all 4 of these failure modes. But this process requires 2 huge shifts in mindset. First, the brutal one. Prototypes are explicitly not products. They are disposable.
Yes. If you find yourself pushing a prototype into production, maybe because it looks really good or a stakeholder is rushing you, that is what the sources call a smell. It's an anti-pattern.
Why is this so bad?
You are sacrificing long-term stability for short-term visual gratification. Prototypes are built for learning speed. They are missing essential production elements like security, performance tuning, robust logging.
All the boring stuff that actually makes a product work.
Exactly. Shipping them guarantees massive technical debt.
And the second point, which I think is truly revolutionary, is that prototypes make a much better specification than documents. Traditionally, product teams wrote a 50-page product requirements document, a PRD.
And engineers then spent weeks arguing about the interpretation of paragraph 3, subsection B.
Right. But now, once a solution is validated by users, meaning the risks are mitigated through testing the high-fidelity prototype, combined with just enough supporting documentation.
becomes the main specification for the engineers. It clarifies the interaction, the visual design, the error states, the exact flow better than any static text document ever could.
The prototype is the spec.
The prototype is the spec. It's a shared, validated reference point for the whole team.
Okay, so if the 4 risks tell us what we need to test, the next strategic question is, how real does this test need to be? And this brings us to the whole concept of fidelity.
Right, and defining fidelity is, on the surface, simple. It's just how closely the prototype mimics the final product. But we have to move beyond just thinking about visual polish.
It's more complicated than that.
It is. Fidelity exists across multiple strategic dimensions, and choosing the right combination of those dimensions is what saves time and maximizes learning.
Our sources break this down into 4 key dimensions, and I think understanding these is key to choosing the right tool for the job. You could be high in one dimension and low in another, right?
Precisely. So first, we have visual fidelity. This is the aesthetic layer. How close does it look to the final UI? We're talking colors, typography, spacing, component libraries, branding.
So if the final product is a slick sauce dashboard, a low visual fidelity prototype might be just grayscale boxes and default fonts.
Exactly. Whereas high visual fidelity will use the exact brand color palette and the exact component library. It looks indistinguishable from the real thing.
Okay, that's visual. Then there is interaction fidelity.
This defines the realism of movement and engagement. Can users actually click through flows? Do the transitions look smooth and realistic? Can they scroll, enter data into a field, and submit a form to see a realistic success or error state?
So a low interaction fidelity prototype might just be a static image, a JPEG, and the facilitator have to manually advance it, forcing the user to say, I would click here.
Right. But a high interaction prototype feels like a fully built app, even though it's all fake. It's just a bunch of linked images, but it feels real.
Next is a dimension that I feel is often neglected, but is absolutely vital for reliable feedback. Content data fidelity.
Oh, this is a huge one. This means using realistic, domain-specific sample data. If you are testing an expense report tool and you use client A, client B, client C, the user just doesn't engage properly.
Their brain kind of checks out.
It does. They need to see Acme Core regional marketing budget and invoice 452239 with a realistic amount like $450,000, 90 days overdue. The authenticity of the content makes the user suspend their disbelief and give you reliable feedback on the value.
Exactly. Using lorem ipsum, or generic data, fundamentally invalidates value testing because the user isn't forced to confront the messy reality of their own job.
And the final dimension is functional breadth and depth. This defines the scope of the prototype.
So breadth is how many flows or features are represented.
Right. Are you showing just the approval flow or the approval flow plus the reporting dashboard? That's breadth.
And depth is how deep those flows go.
Exactly. Does the flow include every single error state, every settings page, and every confirmation modal? You might have extremely high visual fidelity on a single screen, which would be low breadth and depth.
Or you could have low visual fidelity across 20 different screens and error states, which would be high breadth and depth.
Correct. And this helps us categorize prototypes into 3 general buckets based on a blend of these 4 dimensions: low, medium, and high fidelity.
So low fidelity is your thinking tool. This is sketches, paper wireframes, simple white box flows, rough blocks thrown together in Miro or Figma.
They're extremely rough, extremely fast to change, often faster to draw than to discuss, and they're what we call facilitator-driven.
Low fidelity is best used really early on, right? Purely for exploring the problem and solution space, quickly mapping high-level flows, or just getting team alignment on a core concept.
And because they are so rough, no one feels overly attached to them, which is perfect when you know you're going to throw away 90% of your initial ideas.
Then you have medium fidelity.
This is the structural tool. Here, the layout is generally settled, the bones of the experience are there, basic interaction is defined. You might use limited styling, maybe grayscale, but you are focused on the information architecture.
Medium fidelity sounds ideal for testing usability at that structural level. It lets you validate task flows and the IA before you spend time on expensive visual design.
It answers questions like, is the navigation in the right place? Do the labels make sense in context? Is the hierarchy correct?
And finally, high fidelity. This looks and feels very close to the final product. It includes the full visual design and realistic interactions.
Now, wait a minute. High fidelity sounds expensive. It sounds time-consuming. If we are trying to find the cheapest way to learn, shouldn't we avoid high fidelity for as long as possible?
Yeah, isn't spending weeks making a beautiful prototype a huge waste of time if the idea ultimately fails the value risk test anyway?
That's a great challenge, and it really gets to the heart of the modern framework. The SVPG approach strongly favors high-fidelity prototypes for discovery, especially when you're testing with actual users.
Why is that? It seems counterintuitive.
It's because the learning you get from them is exponentially better, even if the upfront cost is slightly higher than, say, a lo-fi sketch.
Okay, unpack that. Why is the learning better?
There are three powerful reasons. Reason one, high fidelity lets you test both usability and the crucial emotional response realistically. We said you can't test trust with a grayscale wireframe.
Right.
If you're building a financial tool, the user needs to feel that the interface conveys security, authority, and professionalism. If the visual design looked cheap or amateur, the user will be psychologically unable to give you honest feedback on the functionality. The visual design is part of the product's value proposition.
So we're testing the whole package, the aesthetic, the feel, the trust, not just the click path.
Exactly. Reason two. High-fidelity prototypes force the team to think through the nuanced details and the edge cases early on. It becomes a kind of compulsory pre-mortem.
How so?
Well, if the designer has to design the exact error message that appears when a user enters an invalid date, they have to consult the technical team about the specific constraints of the API. This process anticipates problems before engineering even starts writing code, and that saves massive time downstream.
That makes a lot of sense. Low fidelity allows you to just hand-wave the details, but high fidelity forces specification.
And reason three, which connects back to what we said in section 1, they serve a dual purpose. They double as the primary specification for the engineering team once the concept is validated.
So why waste time writing a huge document?
When the tested, approved, high-fidelity artifact can serve as the shared truth for everyone.
That dramatically shifts the cost calculation. If the design artifact can eliminate weeks of engineering confusion and documentation, the cost of creating that high-fidelity prototype is easily justified.
But, and this is a critical warning, you have to remember this, high-fidelity prototypes are excellent for learning how someone uses something and how they feel about it.
Right.
They do not prove the product will sell. Just because a few users express positive feelings about a beautiful prototype doesn't guarantee market success or payment or mass adoption. That requires the next stage of testing.
Okay, so this is where we connect the dots between the risks and the actual tools. Choosing the right fidelity isn't just about picking low, medium, or high visual polish. It means picking the right flavor of prototype designed specifically for the risk you're tackling.
Right. And the sources identify 3 core prototype types, each one tailored for a different kind of reality test.
Let's start with flavor 1, user prototypes. This is basically the high-fidelity UX prototype we were just talking about.
It is. They're typically clickable flows built in design tools like Figma, Framer, or Sketch. And their critical limitation is also their greatest strength.
Yeah.
They are entirely front-end focused.
They look real, they feel real, but they're just sophisticated theater.
Exactly. They lack a real backend, real databases, or real security. They're hollow.
So their main purpose is testing value, usability, and that emotional response with target users and stakeholders.
Can they complete the task? Do they like the solution? Do they feel confident using it? They test human perception and interaction patterns. That's their job.
Now let's move to the second flavor, which is crucial for tackling that feasibility risk we talked about. Feasibility or technical prototypes.
Often called spikes.
Spikes, right.
These are quick experiments built by engineers, often for other engineers. There is usually minimal or even zero input from the design team in terms of visual polish. The focus is entirely on technical constraints, performance, and complexity.
You mentioned before that technical fidelity and visual fidelity are independent. Can you give us a concrete example of a spike? Because I think a lot of non-technical people assume a prototype has to have a button.
A great example. Imagine a team wants to implement a new personalization feature. It relies on pulling user history from 3 different legacy microservices, combining that data, and then feeding it into a new proprietary AI model.
Okay, complex stuff.
Right. The question isn't, what does the UI look like? The question is pure feasibility risk. Can we successfully query all 3 services, merge the data, and get a result back to the user within 500 milliseconds, 99% of the time?
So the technical prototype the engineer builds might just be a command line script, or a really basic, unstyled web page with a single execute button.
Exactly. The engineer cares if the command line output shows a latency of 480 milliseconds or 1.5 seconds. They don't care if the button is blue or gray.
So fidelity here is about technical realism.
It's all about technical realism. Is the test environment running the same data volumes and network conditions we expect in production? The purpose is not to test human interaction, but to test machine performance. This is the only way to mitigate feasibility risk efficiently.
That provides the sharp contrast we need. A high-fidelity user prototype answers, will they click the button?
And a technical spike answers, will the server even respond in time if they do?
Okay, and finally the most advanced flavor, the one that bridges discovery and true reality.
Live data prototypes.
This moves beyond even sophisticated simulation. A live data prototype is a thin, usually pretty ugly, version of the actual product that is carefully wired to real live data.
Or maybe launched to a very small, controlled segment of your production environment. We're talking about true A/B tests or small, limited betas here.
And the purpose here is to prove if something works in the real world by measuring objective outcomes.
This is where we stop relying on interview feedback, where people might exaggerate their purchase intent because they're being nice, and we start measuring observed behavior. Are they actually converting? Are they making repeat purchases?
Is the metric we care about, like conversion uplift or behavior change or reduced error rates, is that metric actually moving in production?
Exactly. This is the ultimate test of value. It's moving from, I would use this, to, they are using this and paying for it. The reality of live data, real financial transactions, and actual system performance. It just removes all the cognitive biases that are inherent in user testing.
So when a team chooses a prototype, they aren't just adjusting a slider from rough to polished.
No, they are strategically selecting a focused tool, a user prototype for interaction and emotion, a feasibility prototype for performance and integration, or a live data prototype for objective outcomes, and then applying only the minimum necessary polish to get a valid, credible answer to their question.
We have the 4 risks and the 3 flavors. Now we need to synthesize this into a repeatable, structured approach, the decision flow that guides teams away from just guessing.
Right. And step 1 is, what question are we answering? This sounds so simple, but it is where many teams fail. They just start building before they articulate the specific risk they are trying to retire.
So the artifact, the prototype, must always be built to answer a precise question that's tied to one or more of the 4 horsemen.
Oh.
Let's use the source materials examples to illustrate how crucial framing this question correctly is.
Okay, so if the question is, will sales managers pay a 20% premium for this specific forecasting analytics module, and is it compliant with our new commission structure? What are you testing?
You're testing value, will they pay for it? And viability, is it compliant?
Right. And the fidelity must be high enough to make the managers believe they are seeing a final product and elicit a realistic price reaction.
Okay, different question. Can a first-time user who hates computers successfully complete our new 3-step onboarding process without needing external help or calling customer support?
That's pure usability.
How about this one? Can our underlying architecture handle 10 times the current traffic load if we deploy this new computationally heavy recommendation algorithm across all global regions simultaneously?
That is feasibility through and through. The interface is completely irrelevant. The technical architecture test is everything.
And one more. Does this new dark mode theme comply with accessibility standards for users with moderate visual impairment? And does the microcopy fully comply with Regulation X?
You're testing usability, accessibility, and viability legal compliance.
Okay, so you frame the question first. Then step 2, who is the audience and context? The fidelity you choose is often dictated by who is looking at the screen.
It is, because fidelity has to respect the cognitive load of your audience.
So internal teams, the engineers, designers, and PMs, they can often tolerate very low fidelity or even pure whiteboard sketches.
Why? Because they live and breathe the problem space. They can mentally fill in the gaps, ignoring the placeholder boxes and focusing solely on the structural flow. It saves a ton of time.
But end users or external customers, they require significantly higher fidelity to provide reliable feedback.
Absolutely. If the prototype is too rough, they spend more time trying to understand what the placeholder text means than actually evaluating the solution. That cognitive friction introduces noise, and the learning is invalid. You need to provide enough polish for them to suspend their disbelief.
And the third audience, executives and stakeholders.
This is the high-risk zone. They often need polish for understanding, for support, for resource allocation. But the risk of them confusing the prototype with the finished product is extremely high.
They see a beautiful high-fidelity mock-up and instantly assume it's 2 weeks away from launch.
And that requires very careful management and framing from the product manager.
Okay, so you know the question, you know the audience. Now, step 3. Choose the lowest fidelity that can credibly answer the question.
This is the core mantra of efficient discovery. You are seeking the cheapest, fastest representation that still yields valid, trustworthy learning. If a paper sketch can credibly convince you a workflow is broken, don't spend 3 days in a design tool building it out.
Let's do a detailed breakdown of how the risks map to the necessary fidelity, moving from that lo-fi exploration to the hi-fi reality.
Okay, so for value risk, will users care? The fidelity evolves. You start with low fidelity, using storyboards and early interviews just to gauge the reaction to the concept. That's enough for an initial sense check.
But then you have to move up.
You have to. Later, you must transition to high-fidelity UX prototypes to evaluate the emotional fit and the perceived value. If it looks cheap, they won't value it highly, regardless of the function.
But the ultimate proof for value is the live data experiment.
That's the only place you can measure actual intent. Did they commit to buying? Did they actually use it repeatedly? That's the only truth.
Okay, how about for usability risk? Can they use it?
The requirement there is typically medium to high fidelity. You need realistic navigation and microcopy. A medium fidelity wireframe might test the basic sequence, but the SVPG approach often insists on high fidelity usability testing because, again, visual design directly influences trust and user confidence.
Which impacts how they behave when they confront an unfamiliar interface.
Exactly. For feasibility risk, can we build it? We are dealing almost entirely with technical prototypes or spikes. The fidelity concern is purely technical realism, not visual realism.
And for viability risk, does it work for the business?
It demands high enough fidelity that internal stakeholders, legal, finance, marketing, can realistically assess the risk. You cannot test compliance with GDPR if the prototype uses lorem ipsum in the consent flow.
Right. Legal needs to see the real microcopy, the real links to the terms, and the exact flow before they can sign off on the risk.
Which leads to step 4, fidelity evolution across the cycle. You don't just build one prototype, you move through a deliberate progression, often multiple times a week.
Multiple times a week.
The sources stress that top teams do. Fast learning requires this iterative cycle. It starts with low fidelity exploration to define the problem. Then you refine the structure with medium fidelity wireframes to lock down the information architecture.
Then high fidelity UX to test trust and emotion.
And finally, a live data prototype or beta to prove the objective results in reality.
So the constant driving question for the team is never about perfection.
Never. It's always. What is the next riskiest thing we must learn? And what is the cheapest prototype that can teach us that? It's a relentless, risk-first approach to iteration.
Let's ground this theory in action. We can use these structured examples to show the framework's flexibility across different problem spaces.
Good idea. Let's take case 1, a B2B workflow tool automating invoice approval. The target user is a finance manager. The core value is reducing time to approve and reducing human error.
So the initial steps are purely conceptual.
Exactly. Step 1, whiteboard and lo-fi wireframes with finance managers. They are only trying to sense-check the problem framing and the high-level workflow. The conversation is just, do we understand the steps they currently take? This checks initial value risk. The prototype is just a conversation aid.
Okay, once that high-level flow is agreed upon, they focus on execution.
Step 2, medium-fi prototype of the main approval flow. This is designed for structural usability testing. Can the user find the invoice, check the necessary data points, and hit approve without confusion?
So if the labels are wrong or the data hierarchy is confusing, this prototype will expose it.
Right. Then comes the trust layer. Step 3, hi-fi prototype including visual design and realistic data. Since this involves high-stakes finance sign-offs, the visual design has to convey security. They are now testing comprehension and confidence.
Will the manager trust the numbers they see? This is testing refined usability and viability.
And the final, undeniable proof. Step 4, a live data prototype for one small control department for 2 weeks. They measure objective time to approve and error rates against the manual baseline.
Did the product actually deliver the business benefit of efficiency? This is the ultimate test of objective value.
Okay, let's switch gears. Case 2, a consumer saving app. This product relies heavily on emotional connection and habitual use to mitigate value risk.
So the early stage focuses on motivation and emotional engagement.
Totally. Step 1, storyboard and lo-fi prototype in interviews. They ask, would you use this goal-based saving feature? What goals motivate you? Since the product relies on changing personal habits, the team needs to know if the core idea even resonates before they start designing screens.
Then they jump fast to polish.
They have to. Step 2, hi-fi prototype. They need to test the emotional response. If the app deals with someone's money, it has to feel secure, stable, and aspirational. Does the onboarding flow feel motivating? Does the design create trust? This tests the emotional component of value and usability.
And finally, the behavioral check is everything.
It is. Step 3, live data experiment. A small beta group is invited to see if people actually deposit money regularly. This is the crucial leap from "I like the idea" to observed action. The team only mitigates value risk once they see users committing their own money repeatedly.
These examples really highlight the core principles of prototype testing. And it must be rigorous. We can't just conduct show-and-tell sessions.
No, you need tasks, not tours.
Okay, so the core principles are simple, but often ignored. First, test with real representative users. Don't use your internal colleagues who have way too much context.
Second, give users tasks, not tours. This means simulating the real context and goals of the user. Instead of walking them through the screens, give them a problem to solve.
So for instance, if you're testing that saving app, you don't say, now click here to set a goal.
No. You say, you just got your paycheck,
Yeah.
and you are trying to save $1,000 for a trip next summer. Show me how you would set up that savings plan and deposit the first $50. This simulates the real pressure and context.
Okay, third principle.
Maintain absolute neutrality. Avoid leading questions. If you lead the witness, the entire test is invalid. Never hint at the correct action. Just observe their behavior, record their confusion, their hesitation, their success rates.
Fourth, look for statistical patterns across several participants. One user saying, I wish the button was red, is just subjective noise. It's an opinion.
But if 4 out of 5 users fail to find the submit button, you have discovered a critical design flaw, and that is evidence you must act on.
And fifth, capture insights and iterate quickly.
The goal is better decisions and improved prototypes, not a polished 40-page research report that takes 3 weeks to write. The measure of success is whether participants can complete those realistic tasks with minimal artificial scaffolding. If you have to spend half the test explaining the interface, your learning is flawed.
Okay, so moving from that stress test with users to the internal review, we need to tackle the art of critique. I think many teams fundamentally misunderstand this meeting.
Oh, completely. They confuse a critique session with a brainstorming meeting where everyone just tosses out suggestions based on their personal taste.
But that's not what it is.
Not at all. A critique, as defined by the framework, is a focused, goal-oriented decision-making meeting designed purely to improve the prototype and mitigate the 4 horsemen. It is explicitly not a free-for-all for personal preferences.
And it has to happen constantly. This is where the prototype of the day ritual comes in.
This is a lightweight, frequent practice where the core trio, the product manager, the product designer, and the tech lead plus maybe 1 or 2 others, spend 15 focused minutes reviewing the absolute latest iteration.
15 minutes. The point is speed.
Frequency and speed of feedback trump formality. If you wait until the big weekly design review, you've lost days of potential iteration time.
So what are the goals of this quick meeting? First, check alignment. Does this prototype still align with the original problem statement, goals, and constraints?
Second, identify conceptual or usability issues early before you waste time testing a fundamentally flawed concept with external users.
Third, bring multiple perspectives to bear on the problem.
Right. The designer looks at aesthetics and flow, the engineer looks at feasibility, performance implications, and potential technical debt, and the product manager is looking at value, viability, and market fit.
And fourth, and most importantly, the goal is to decide what to change next to address the highest remaining risk.
It is a decision-making session, not just a discussion about likes and dislikes. If you walk out of that meeting without a clear next step, the critique failed.
Who should attend?
The core should always be the product manager, product designer, and tech lead. These 3 roles are mutually accountable for the success of the solution. They cover the 3 core risks: value and viability, usability, and feasibility.
What about others? Can an analyst or a stakeholder join?
They can, provided they respect the structured format and contribute evidence, not just opinions.
Let's walk through the required structure for a critique session because that structure is what prevents it from becoming a political battle.
Okay, step 1, set context, 2 to 5 minutes. The presenter, usually the designer, must start by stating the problem, the target user, and the key metrics. And crucially, they have to specify which risks this prototype is focused on.
For example, we are testing the feasibility of the API calls and the initial usability of the data input screen.
Precisely. And they state what specifically changed since the last review. No one should be allowed to comment until this context is fully set.
Step 2. Walkthrough, 5–10 minutes. The designer or PM walks through the critical flows only. They focus on the specific user tasks and decisions this iteration addresses.
And the walkthrough should mimic the external user testing scenario, focusing on what the user is trying to achieve.
Step 3. Structured feedback, 10–25 minutes. This is the heart of the process. You can use frameworks like I wish I wonder, but the ground rules here are everything.
And the primary ground rule, which the PM has to enforce rigorously, is to focus only on user outcomes, evidence, and the 4 risks, never on personal taste. This is where the PM has to act as the protector of the company's investment.
So if the tech lead says, "I don't like the color of this warning,"
The PM has to pivot immediately. The PM needs to ask, what behavior are you worried about here? Is the color leading to a feasibility risk or a usability risk where the user might not understand the severity?
so you tie it back to the risks.
Always. Now, if the tech lead says, I don't think this can handle more than 50,000 requests per minute, now that is a critical feasibility risk, and that feedback is valid and essential.
Similarly, if a stakeholder says, "I think we should move the button to the left because I prefer it there,"
The PM has to say, that's helpful, but we anchor our feedback in the problem statement. What user outcome are you worried about with the current position? This protects the process from subjective politics.
Okay, step 4. Prioritize and decide, 5–10 minutes.
The team clusters the structured feedback. Which of these risks are now mitigated and which are the next most dangerous? They decide on 1 to 3 key changes for the next iteration and identify any new risks or questions that the current prototype brought to light.
So you walk out with clear, actionable tasks for the designer and engineer.
Yes. And step 5, document outcomes. Short notes on decisions, assumptions, and new questions. You document the link to the prototype version. This short record becomes part of your discovery evidence trail. It provides accountability and historical context for the learning process.
And the focus of the critique evolves with fidelity.
Right. It has to. Early low-fidelity critiques focus on flows and core concepts. Medium fidelity focuses on layout, hierarchy, and information architecture. And later, high-fidelity critiques focus on microcopy, visual design, and comprehensive error handling. The complexity increases as the team gets closer to mitigating all 4 risks.
Even with this detailed framework, teams, especially when they're rushed or politically constrained, often fall into predictable traps. Recognizing these anti-patterns is just as important as knowing the right steps.
This is where discovery dies. And the first, deadliest trap is confirmation bias discovery.
The team has fallen in love with their solution.
They have, and they are only testing with friendly users, asking leading questions during interviews, or critically actively ignoring or dismissing negative feedback because the data conflicts with their emotional attachment to the idea.
They are actively avoiding the truth. This kills value risk and guarantees a failure once the product hits the broader market.
The fix is proactive. You have to predefine quantifiable success and failure signals, and you must actively seek disconfirming evidence. You should be trying to break your solution, not prove it's right.
Okay, anti-pattern number 2. Ship the prototype. We mentioned the smell earlier, but this is a full-blown disaster scenario.
This is when a beautiful, high-fidelity prototype gets approved by an executive who insists it goes straight into production next sprint, bypassing all the quality gates of engineering delivery.
And the consequences are severe. Prototypes, while they look real, are built with shortcuts. They lack security testing, proper error handling, logging, monitoring, performance tuning.
All the stuff that makes a product stable. Shipping them guarantees massive technical debt that will slow the entire product organization down for months or even years.
The fix requires strong product and engineering leadership to rigorously separate discovery artifacts, the disposable prototypes, from delivery artifacts, the stable, shippable increments.
Okay, number 3. Over-documenting instead of discovering. This is a regression to the old way of working.
A team spends weeks writing a long product requirement document, a PRD, detailing every possible scenario and edge case in a futile effort to define reality upfront.
Instead of investing that time in building and testing prototypes that force the team to confront reality immediately.
Prototypes are simply a more efficient communication tool than a document. They resolve ambiguity faster than any text ever could.
The fix is cultural. You have to use the prototype as the primary spec, relying on only minimal supplementary documentation to cover things like performance targets or legal requirements that the prototype can't physically show. The prototype is the primary truth.
Number 4. Big bang hi-fi with no iteration.
This is the perfectionist trap that trades learning speed for aesthetic idealism. A team spends weeks perfecting one beautiful prototype, only to test it once, maybe with 5 users, before declaring it done.
But discovery demands short, ugly, frequent cycles. You need speed.
The fix is structural. You have to enforce short discovery cycles with frequent iterations and daily or weekly critiques. It is far better to test 5 rough prototypes in a week and learn 5 different things than to test one perfect prototype in a month and only confirm one idea.
And finally, number 5. Stakeholder-led design in critique.
This is the political failure where the whole evidence-based system just collapses. A senior person uses the structured critique session as a platform to dictate a solution based purely on personal preference or organizational momentum, undermining the evidence gathered from users.
This is the moment the PM earns their salary.
It is. They have to protect the discovery process by anchoring all feedback, even from the most senior executives, in the problem statement, the target user needs, and the external evidence gathered from testing.
The PM needs to have the organizational spine to say, that's an interesting preference, but the data suggests users fail that task 80% of the time, so we need to prioritize solving that usability risk first.
The evidence must always trump the title.
We've covered a massive amount of ground today, moving from the philosophical strategy of minimizing risk to the granular structured practices of running effective internal critiques. Let's reinforce the essential principles for you, the learner.
First, prototypes are scientific instruments. They are tools designed to test the 4 risks: value, usability, feasibility, viability. They are not mini products. They are high-speed risk mitigators designed to be thrown away.
Second, fidelity is not arbitrary. It is a strategic choice. You must use the minimum level of realism required to credibly answer your current question. Don't waste time polishing something if a sketch will do, but also remember you can't test trust with a grayscale wireframe.
Third, high-fidelity UX prototypes are powerful because they test that crucial emotional response of the user, and, once validated, they can transition seamlessly into the product specification, saving the engineering team immense time and avoiding ambiguity.
Fourth, the ultimate test is the live data prototype. This is the truth machine. It moves your team from subjective interview feedback people saying they will use it to observed reality, actually measuring if they use it, convert, or change their real-world behavior.
And finally, good critique must be structured, frequent, and strictly goal-driven. It is a meeting focused on evidence, risk, and decision-making, never a design popularity contest or a political platform.
This entire framework is designed to make product teams fast, efficient, and, most importantly, right. It's about building confidence and minimizing your failure rate before you ever commit serious capital.
And that leads to our final provocative thought for you to mull over. We've learned that the limiting factor in product discovery is never the technology or the tools or the aesthetics. The limiting factor is always the speed of learning.
So the next time you encounter a polished, beautiful product that seems to solve a need perfectly, ask yourself, was this feature built to learn, or was it built to earn? And how quickly did that team iterate through the 4 horsemen value, usability, feasibility, and viability to get to that polished state?
Keep learning fast, and we'll catch you on the next deep dive.